Okay, so in the world of heavy industry, there's this one process that's like the final guardian of safety for any equipment that's going to be under high pressure. It's all about making sure it's strong enough before it ever goes into service. And today, we're going to break down exactly how that works and the standards that make it happen.
And look, that's not just some line buried in a technical manual, right? It's the absolute final, non-negotiable barrier that stands between a safe, reliable operation and a potential catastrophe. Getting this one step right is, well, it's everything.
So let's be super clear about this. We're not talking about a best practice or just a good idea. This is an absolute mandate. It is a required step, and it's designed to protect people, super expensive equipment, and of course the environment from serious harm.
So, what are we really looking for during these tests? What's the point of all this? Well, we're basically giving the whole system a final exam. We're confirming that every single weld is strong, that the metal is thick enough to handle all that stress, that there are absolutely zero leaks, not even a tiny one, and that the most critical parts, like the safety valves, actually work the way they're supposed to. It's a top-to-bottom system check. That brings us to the next big question, right? How do you actually do this? How do you perform this kind of critical verification safely and effectively? Well, there are two main ways, two primary methods that you really need to know about.
First up, we've got hydrostatic testing. Now, you should think of this as the gold standard. It is by far the most common, the most widely accepted, and, most importantly, the safest way to test for pressure integrity.
Now, the real magic here, the key to the whole thing, is that it uses an incompressible fluid. And that's almost always just plain old water. Because water doesn't really compress, it stores very, very little energy, even when it's under enormous pressure. And trust me, that is a critical safety feature of this whole method.
And this is where it gets really interesting. We're not just testing to what it can handle on a normal Tuesday, you know? The international standards actually require us to push it way, way further, usually to about 1.3 to 1.5 times its maximum allowable working pressure. We're doing that to prove it has that built-in safety factor we're counting on. And this whole process is anything but random. It is rigorously controlled by major international standards like ASME, the European Pressure Equipment Directive, and ISO. These massive codes dictate every single part of the test to make sure it's done correctly and safely no matter where you are in the world. All right, on to method number 2, pneumatic testing. And you'll probably notice the subtitle here, the high-risk alternative. The tone definitely shifts because this method is only used when it is absolutely, positively necessary.
Okay, so this is the absolute core difference, and you've got to understand this. Instead of a nearly incompressible liquid like water, pneumatic testing uses a compressible gas, like air or nitrogen. And what that means is you end up with an exponentially higher amount of stored energy. It's like comparing a firecracker to a bomb. Both are pressure tests, sure, but their risk profiles are just worlds apart.
And all that stored energy means that if something goes wrong, it's not going to be a simple leak. No, it's a violent, explosive release of all that pent-up energy. A failure during a pneumatic test can be, and often is, absolutely catastrophic.
All right, so the big question, the one you're probably thinking right now is, why on earth would anyone ever use this method? And that's a totally fair question. The short answer is, you don't choose it. You use it when you have no other choice. It's really just for those situations where a hydrostatic test just won't work, like if the equipment can't physically support the massive weight of all that water, or if even a little bit of leftover water would contaminate the whole process later on.
Because it's so incredibly dangerous, the procedure for pneumatic testing is unbelievably strict. You don't just crank up the pressure. You do it in careful, gradual steps, with specific hold times in between each step. Leak detection has to be meticulous, often with something as simple as soapy water. And this is the big one. It is absolutely mandatory to get all non-essential personnel out of the area, no exceptions.
Now, whether you use the safe method or the risky one, the job isn't over when the pressure comes back down. The final, crucial phase is all about compliance, which really means documenting the proof that it was done safely and that it passed. And that proof has to be solid. I'm talking about formal, written procedures that were approved before the test even started. You need to show that you use calibrated gauges and instruments. You have to issue a formal test certificate, and you need inspection records that are completely traceable. You need the whole paper trail. Because in this world, if you can't prove it, it basically never happened.
For the engineers, the inspectors, the managers, everyone involved, compliance is not a choice. It's not optional.
It is a fundamental, non-negotiable part of their professional and ethical responsibility. End of story.
Because when you strip it all away, all the codes, the paperwork, the complex procedures, it really boils down to one simple, powerful truth. Following these rules correctly, responsibly, it isn't just about protecting a piece of equipment, it's about protecting people. Pressure testing saves lives.